Hey everyone, this is the Algebra 2 Unit 6 test number 2 practice test. So we'll work through these and see how it goes. Now, question number 1. Question number 1. So they give us a parabola here. They give us a function x squared minus 14x minus 15. And they're asking for a couple of things here. They're asking for f of negative 3. They're asking for the vertex, and they want to know the y-intercepts, and they also want us to find the x-intercepts. So part D, right, when the function is equal to 0, those are the x-intercepts, or the solutions. Okay, so they're asking for all that information. I'm going to work this a couple of different ways. So if we don't have a graphing calculator, right, we can still figure this out. If I were to factor this, right, put this in factored form, I'd be looking for the factors of 15, right? They give me negative 14, and so this would be x minus 15 and x plus 1 is how I would factor that. And the reason that I care about that is that that tells me my zeros. That tells me my x-intercepts. So my x-intercepts are going to be x minus 15 is equal to 0, and x plus 1 is equal to 0. So that tells me that it's going to be where x is 15 and where x is negative 1. Okay, so that gives me the answer to part D on that. And so that's going to be negative 1 and 15. Okay, the y-intercept, okay, the y-intercept where the x value is 0, that's just my constant term. Okay, if I put 0 in for this, this term becomes 0, this term becomes 0, and I just get negative 15. So negative 15, so that's going to be my y-intercept. All right. Okay. So the other two, I can calculate those, okay, and it's not a difficult thing to do. If I look at my factored form here, if I put in negative 3, I would have negative 3 minus 15 times negative 3 plus 1. That would give me negative 18 times negative 2. That would give me positive 36. Okay, so when I put in negative 3 for x, I should get positive 36 as an answer. All right, and the vertex, so if I look at my zeros here, right, I have a 0 at where x is equal to 15 and where x is equal to 1. If I thought about that on a number line, right, there would be 16 units in between those. So halfway through there is going to be where x is equal to 7, right? So that's going to be exactly halfway through there. So it's 8 minus 15 or negative 1 plus 8, so it's halfway in between. That's going to be my axis of symmetry, and if I plug this into my equation here, so I would have plug in that equation, that would be 7 minus 15 times 7 plus 1. That's going to give me, what is that, negative 8 times 8. That's going to give me negative 64. So my vertex is going to be at the point 7, negative 64. Okay, so that's going to be my vertex. This is my axis of symmetry. Okay, so and the way I got that 64 was I just found, I just plugged in 7 into my function, right? And I plugged it into the factored form because that's a little easier to calculate than squaring those numbers and so forth. All right, so that's one way to do it. So I have a vertex at 7, negative 64. Okay. Now, the other way to do this is just to simply take this equation and put it into a graphing calculator and look up the answer. So if I copy this and I switch over to Desmos, I can paste this function in. I need to change that to a squared. And so I could see that parabola right there. Okay, so there's my parabola, and I can just check these points out. And so I could see at negative 1 and 15, right, negative 1 and 15, those are my x-intercepts. I can see my y-intercept is at 0, negative 15. Okay? I can see my vertex here is at 7, negative 64. Right? And if I wanted to look up where x is equal to negative 3, I could just simply turn this into a table of values and look up negative 3. And I would see that that's 36. Okay, so either way is fine to do it. This was a nice one just because it's easy to factor, and those numbers came out nice and easy. Some of them don't always do that, and so it's good to know how to do it, manually, right, without the graphing calculator. But it's also handy to have that graphing calculator to check and make sure that everything's right. So switch back to our problems here. And so I think we're all good here. I'm going to zoom in on this just a little bit. Make it a little bit easier to read. Okay, and so I think we're all set here, so we'll go ahead and submit that. And it looks like we did okay on that. All right. The similar thing here, they're asking us about this parabola, and so I can go through and make those calculations again. I'm just going to use my graphing calculator to look these up. And so I'll go ahead and copy this, switch back over to Desmos. I'll go ahead and clear this equation out of here. Paste this one, change that to a square, make sure it came in okay, and then I can zoom in down here and look at this a little easier. Okay, so there's my parabola. They're asking me for the x-intercept. The smallest is going to be negative 4. So number 2, the smallest x-intercept is going to be negative 4, 0. The other x-intercept is going to be 1, 0. Okay, my axis of symmetry and my vertex is halfway in between that. That's negative 1.5. So the vertex is negative 1.5, 6.25. And then my y-intercept is at 4. I can see that pretty easily from the equation. And they asked me for the line of symmetry. So the line of symmetry is going to be this vertical line right through there. That's going to be where x is equal to negative 1.5. And so we've got the x-intercepts, we've got the y-intercept, we've got the vertex, and we've got the line of symmetry. Okay, so not hard to just plug this in and look these values up, but you do have to know what you're looking for. Okay, so switch back over here to our question. Oh, sorry. I forgot to switch to Desmos. There's the equation in Desmos. Okay, so negative x squared. And you can see all the points, right, that I've selected there. Okay, so here are the x-intercepts. Here's the y-intercept, the vertex, and the axis of symmetry goes right down through the middle. The axis of symmetry goes right down through that vertex right there. And so if I wanted to show that, I could just say, x is equal to negative 1.5, and there's my axis of symmetry. Okay, so I can get fancy with that as well. Right, so there's my axis of symmetry, is where x is equal to negative 1.5. There's my other points are all on there. Okay. All right, so let's switch back to our problem here, and so we can fill this out. The leftmost x-intercept is where x is equal to negative 4. The rightmost was where x is equal to 1. The y-intercept was at the point 0, 4, so the y value there is 4. The vertex is at negative 1.5 was the x value, and the y value was 6.25. And the line of symmetry is going to be x equals negative 1.5. Now we need to make sure and put that that x equals is in there, right? Because that's an equation. It has to have an equal sign in there. So we don't just want to put the number in there. Okay, so question number 3, similar thing here. So they give us the function. They tell us that f of x is equal to negative x squared plus 10x minus 7. Okay, and so this one doesn't factor easily, right? If I look at the factors of 7 and I'm trying to make a 10 out of them, they don't quite work. So so it's not an easily factored one. So this is one where it would really be a good idea to use the graphing calculator. So I'll go ahead and copy this. This time I'll actually switch to Desmos. There's Desmos. We'll clear this last one out and we'll paste this one in here. Control V. Change that to a squared. And so here we have our parabola there. And in this question, they're asking us for the value of f of negative 2. So when x is negative 2, what's my value going to be? And so I can see, right, at negative 2, it's going to be down here a ways. It looks like, you can kind of sneak up on it there and see, but an easier way is just to look it up. And so I can see it looks like it's 31, negative 31, but I can just turn this into a table of values and do it that way as well. And so I can see at negative 2, I get negative 31. So f of negative 2 is negative 31. They want to know the vertex of this, and so we're going to zoom back up here, find the vertex. The vertex is going to be here at 518. And they want to know the y-intercept, okay? And the y-intercept here should be negative 7. And so I can see here when x is 0, my y value is negative 7, and I can also see it's the constant value. So my y-intercept is at 0, negative 7. Okay? And then the last part of the question, they ask you to find the values that make that function equal to 0. So what they're actually asking for here are the zeros of this function. And so I can highlight them there. And you see that they're not just even integers. So we can see that function did not actually factor very well. So it's 0.757 and 9.243. So these are my zeros, or my x-intercepts, or my solutions, or... Okay, so I think we've got everything captured there. So switch back to our problem here. And so I've written down some of that information there. And so again, here they're going to a little bigger. And so they ask us for the value of f of negative 2. That we said that was negative 31. The vertex was at 518. The y-intercept was at the point 0, negative 7. And then they ask us to find the two zeros, right, the two solutions, and they want us to round those to 2 decimal places. And so that would be 0.76, and 9.24. Okay, moving on to question 4 here. Similar sort of a thing here, so they give us number 4. So here they give us the function is 4x squared minus 4, okay? And I can actually see that this is the difference of 2 squares, all right? So there's a couple things I can do here. One is I can just factor this, right, taking the GCF out, and so I get x squared minus 1. And then I can also factor this because this is a difference of squares, and so I can actually write this as x plus 1 and x minus 1. Okay? So that's a pretty easy one to factor there. I also know that when I have a difference of squares like that, right, my axis of symmetry is the y-axis. It's where x is equal to 0. Okay? So my y-intercept and my vertex are going to be the same point. So I know that on this question, on this parabola, my y-intercept is 0, negative 4. Right? If I put 0 in for x and multiply that out, I get negative 4. And then the x-intercepts, right, the x-intercepts are going to be where x is equal to 1 and x is equal to negative 1. Okay? Those are going to be the two values that give me, right? So for this one right here, right, where x plus 1 is equal to 0, that's going to be x is negative 1. And where x minus 1 is equal to 0, that's going to be where x is equal to plus 1. So there's my two x-intercepts, okay? And so, and again, I can go to Desmos and verify that if I want to, but you know, this is a pretty easy one to factor. It's pretty easy to visualize what this looks like. So I think we're good with this. So the vertex here should be at 0, negative 4. Okay. The x-intercept, the value of the largest x-intercept is where x is equal to 1. And the value of the y-intercept, the y is going to be negative 4. Okay. Question number 5. So they're just asking us to factor that. So we've got x squared plus 9x plus 18. And so I want the factors of 18 that add up to 9. And so that's going to be 6 and 3. So I'll have x plus 6, x plus 3. Six, asking us to factor that. So this time we have z's, z squared plus z minus 20. And so I'm looking for the factors of 20, right, that have a difference of 1. So it's going to be 4 and 5. And my middle term here is positive. That means my 5's got to be positive and my 4's got to be negative. So I have x minus 4 and x plus 5. Oh, and I hope you see what I did there. That should actually be a z, right? As I even said at the beginning that this was z's, and then I went ahead and put in x's anyway. So z minus 4, right? Z minus 4, and z plus 5. That's a very common mistake. I make that mistake all the time. I get excited about the problem and don't pay attention to the variables. All right, so let's try that again. That looks better. Number 7, they ask us to factor that completely. I can tell that that's the difference of two squares. Right? 121 is 11 squared, and t squared is t squared. And so this is going to be t plus 11 and t minus 11. So the difference of two squares, right, we just take the square roots. One's positive and one's negative. So this time we've got t minus 11 and t plus 11. Okay, so number 8. So we've got 144 y squared minus 121. Again, this is another difference of squares. It's really helpful to know your perfect square numbers. 144 is 12 squared, so this is going to be 12y, and then 121 is 11 squared, so minus 11. and then we'll have 12y plus 11. Y minus 11 and 12y plus 11. Okay. And again, it doesn't matter which order. Like I could have put 12y plus 11, 12y minus 11, put it in whatever order I want. But they do, you have to have a positive and a negative. That's really what we're looking for. Number 9. Okay, so I need to factor that, and I could factor this. I could use the magic X method. I could just do kind of guess and check thing. But I do notice that I've got some squares here, right? So 4 is a perfect square, 121 is a perfect square. So this is 2 squared. This is 11 squared. 2 times 11 is 22, and there's 2 of those. That's 44. This is a perfect square polynomial. So this actually factors out to 2w plus 11 squared. Okay, and so the pattern there, right, is this squared on the first term, this squared on the last term, and then the middle term is this times 2. Okay, because when we combine those middle terms, we get 2 of them. So it would be 22 times 2 give us 44. So again, those special patterns, like if you recognize them, it really is a huge time saver. That's 11. And then that's just going to be squared. And I didn't type it in. There we go. Okay, so I need to slow down a little bit and check these before I submit. There's a couple of them that I've kind of messed up that way. But hopefully you're not doing the same thing. Question number 10. So here they give us r squared plus 6r plus 9. Again, I recognize that, right? I have a perfect square here, and I have a perfect square here. This is 3 squared and r squared. So 3 times r is 3r times 2 is 6. This is going to be r plus 3 squared. Okay, so double check that real quick. R plus 3 squared. All right. Okay, so number 11, 10 y squared minus 7 y minus 12. Okay, we're asked to factor that completely. Now this one's a little trickier because, right, this is not a perfect square. So 10 is not a perfect square, 12 is not a perfect square. So I need to look at the factors of 10 and the factors of 12 and try to combine those somehow to make a factor, that middle term of negative 7. There's no common factor here, so I'm going to use the X method. Okay, so this X method. The X method says I multiply the leading coefficient and the constant. So that's going to be negative 120, and I put that in the top of my X. In the bottom of my X, I just put the coefficient of the middle term, so negative 7. And now I'm looking for the factors of 120 that add up to negative 7. Okay, so the factors of 120 that add up to negative 7. Let's see what those are. Hopefully we can figure that out pretty quickly. I know that 12 and 10, right, are factors there. What else? That has a difference of 2. I can do 1 and 120. I can do 2 and 60. I can do 3 and 40. I can do 4 and 30. I can do 5 and 12. No, 5. be 5 and 24. 5 and 24. 6 and 20. 7 doesn't go into there. 8, I could do 8 times 15, and I think that that's 8 and 15. So there's a difference of 7 there. Okay, so that took a little bit of work to go through there. I know that to get a negative 7 here, this has to be a negative 15. So I'm going to put those two factors here, 8 and negative 15. And then my last step here is I want to divide those two numbers by that leading coefficient. So divide by 10, divide by 10. So if I rewrite those, this is actually going to be this is going to be 4 over 5, and this one's going to be negative 3 over 2. Okay, now these numbers here tell me my factors. So when I go to factor these out, it's going to be, this is my x term, so this is going to be 5x plus 4. 5x plus 4. And then this fraction here is the other one. This is going to be 2x minus 3. These are actually going to be y's. And I did it again. 2y minus 3. Okay? So that's how that factors out. And, we can take a couple of seconds here and just verify that. So 10, 2 times 5 gives me 10y squared. And then if I multiply those, I get positive 8. If I multiply those, I get negative 15. And so negative 15 plus 8 gives me negative 7. And then 4 times negative 3 gives me negative 12. So that looks like that works. And so I've got 5y plus 4. And I'm using y's here. Okay. And 2y minus 3. 2y minus 3. All right, so the next one, they ask us to factor this. And so this is kind of a different looking one. This is number 12. So they give us x cubed plus 5x squared minus 6x minus 30. And so this is not a quadratic trinomial. Okay, it's not a quadratic trinomial. So we got to think about factoring this in a different way. And so we're going to do this. We're going to factor it as a group. Okay, so we're going to use some grouping here. And so I'm going to look at these first two terms here, and I'm going to see if they have a common factor. And they do. It's x squared. So I'll take x squared, and I'm left with x plus 5. So if I just factor that first part of it, I can do that. Okay. The second part of it, I'm going to look again for a common factor. And so I notice I've got a negative 6 and a negative 30. Negative 6 goes into both of those. And when I factor that out, I would have x plus 5. And this is really what I'm trying to create here. Now I've got another common factor here of x plus 5. And I kind of messed up here because I didn't just take out an x. This is an x squared that I took out, right? Because this should be x cubed and then 5x squared. All right. So, but the process kind of is the same there. We're looking for a common factor now. So x plus 5 is a common factor. So if I factor out x plus 5 out of these, then what I'm left with is x squared minus 6. And so that would be my factorization. I would want to look at this here and just make sure that this isn't a perfect square. And it's not, right? It's not a difference of squares. I can't factor that. So we have x plus 5, and we have x squared minus 6. So x squared minus 6. Okay, and again, we can go through and multiply this out and just verify. So x times x squared gives me x cubed. 5 times x squared gives me 5x squared. Negative 6 times x gives me negative 6x, and 5 times negative 6 gives me negative 30. So if I multiply that back out, I end up right back where I started, and so I'm pretty sure that that is correct. Number 13, So they're asking us to factor this. We have 5x squared minus 720. Okay. Now, I don't have a difference of squares because 5 is not a perfect square and 720 is not a perfect square. But I see that if I factor a 5 out of that, I might be able to do that. Okay. And so I know that 5 goes into 720 because it's got a 0 on the end. I don't know what that is off the top of my head, but let's just check here real quick. So that goes in 1, that's 5, that's 2, that's 2, that's 4, that's 20, subtract, I get 2, so it's 145. Okay, so 44, sorry, 144. There we go, that's better. So 144. So if I factor a 5 out of this, I get x squared minus 144, right? And that 144, like that's what I'm looking for there, because that is a perfect square. And so this is going to be 5, x plus 12, x minus 12. So 12 squared is 144. And I was looking for that perfect square, and I saw that I didn't get that perfect square because I wrote a 5 instead of a 4. So that's what kind of alerted me to my problem there. But I think we're in good shape. So we've got 5. We've got x's here, so this is going to be x minus 12 and x plus 12. Number 14, a similar thing. I've got a difference there. I'm hoping that I can find a GCF and turn that into a difference of squares. And so I've got 5z to the third power minus 45z. And I can see they both have a z in them. There's a 5 that's a factor of both of those, so I'll take a 5z out of that, and I'm left with z squared minus 9. And so there's a difference of squares. And so I've got 5z. And again, I'm writing the wrong variables here. Z plus 3 and z minus 3. So I've got 5z. And then I've got z plus 3 and z minus 3. Plus 3, z minus 3. Okay. So we'll come over here. So number 15, they're asking us to factor this. This is similar to the one we did here on number 12, where we're factoring by grouping. They've already done some of that factoring for us already. So we've got x times x plus 2 minus 8 times minus 8 times x plus 2. And so again, I see that common factor there of x plus 2. So if I factor that out, x plus 2, then I have x plus 2 times x, and x plus 2 times negative 8. So there's my factorization of that. Okay. Now, if you didn't see this this factor by grouping here, you could actually multiply these all out, and then and then try to factor the result. So you could expand these, combine your like terms, simplify that, and then try to factor the result, which you'll get there. But it's a number of extra steps. So if you can see that factor by grouping there, that will save you a lot of time. So we've got x plus 2 and x minus 8. Number 16, so they've given it to us in factor form. So x minus 9 times x minus 6 is equal to 0. And all they're asking us to do is to solve that, right? They want us to know what values of x would make that 0. Well, we use the zero product property, and that says if I'm multiplying two things and my result is 0, then each one of those factors could be 0. So x minus 9 could be 0, or x minus 6 could be 0. So that means that x could be 9 or x could be 6. Okay, so if I plugged in 9 or 6 into that equation, I would get a 0 for an answer. So 6 and 9 are my numbers. And again, you could verify that. You could put that into a graphing calculator and find the x-intercepts. That's really what those represent. So another way to do that problem. Number 17. So here they're giving us an equation, x squared minus 6x. Oops. So they're giving us x squared is equal to negative 6x, and they want us to solve that. Okay. What they mean by that is they want us to set it equal to 0 and find the values, right, that would make that 0. So if I add 6x to both sides, I would get x squared plus 6x is equal to 0. And so now I'm going to try to factor that, and I can see that has a common factor, x. So I have x and x plus 6, and that's going to equal 0. And so that 0 product property says that x has to be 0 or x plus 6 has to be 0, which means that x could be negative 6. So my values here would be 0 and negative 6. Oops, I forgot to submit that. There we go. Okay, question 18. So they give us x times x plus 13, and they want us to solve that. So it's already in factored form. I know that x has to be 0 or x has to be negative 13. Yep. Number 19. So they give us x squared plus 12x plus 20 is equal to 0. So I'm just going to try to factor that. So I'm going to look for the factors of 20, right, that add up to 12. The factors of 20 that add up to 12, I think it's going to be 10 and 2. So x plus 2, x plus 10. So that means that either x plus 2 has to be 0 or x plus 10 has to be 0, which means that x is going to be negative 2 or x is going to be negative 10. So x could be negative 2 or negative 10. So just a note here, right there, they're using set notation here, right? So you can see that means the set of all those numbers, negative 2 and negative 10. Number 20. So here we have another equation, p squared is equal to 21p minus 108. And so they're asking us to solve that. So the way we're going to solve that is to move everything over to one side and get the right side equal to 0. So I'm going to subtract 21p, and I'm going to add 108. So minus 21p plus 108. And so I get p squared minus 21p plus 108 is equal to 0. Okay, and I'm asked to factor that. Now, factors of 108, let's go through that. 1 and 108, 2 and 54. I think 3 goes into that. That's going to be 36, I believe. 3 and 36. 90 and 18, yep. 4 goes into that, 4 and 27. 27, 5, 6. So that would be 6 and 18. Um, 6, 7 doesn't go into it. 8 goes into it. That's going to be 8. And nope, 8 does not go into it. 9 and 12, 9 and 12. I think 9 and 12 gets us there. That we can make a 20 out of a 21 out of that. So a little bit of a process to go through there and find those, right? So this is a positive number. The middle term is negative. That means that both of my factors have to be negative. So I'm going to have p minus 9, p minus 12. And that's going to equal 0. That tells us that p is going to be 9 or p is going to be 12. So there's our two solutions there, 9 and 12. Again, if you could not figure that out, right, if you couldn't go through and go through that factorization and find those factors, you can put this equation, right, or you can put this equation, the p squared minus 21p plus 108, put that into Desmos, look for the x-intercepts. That's another way to solve that, solve it by graphing. Okay, and then the last problem here, so the last problem here, they talk about a triangle, and so this is number 21, and so they talk about a right triangle, okay, and they tell us that the long leg is 17 feet longer than the short leg. So I'm going to say that x is going to be equal to the length of the short leg. So this is x here. And then this side here is going to be x plus 17. Okay, so the long leg is 17 feet longer than the short leg. And the hypotenuse is 25. The hypotenuse is 25. Okay, so we use the Pythagorean theorem here. We know that x squared, right, the a squared plus b squared equals c squared. So I got x squared plus x plus 17 squared is going to be 25 squared. Okay. Okay, so here we'll start working through this. We have x squared. This is going to be x squared. 17x times 2 is going to be 34x. And then 17 squared is, I don't know what that is, so I'm going to use a calculator to calculate that. And so that's 289. 289 is going to be equal to 25 squared. So 25 squared. And 25 squared is 625. Okay, I'm going to combine my like terms here, so I have 2x squared plus 34x plus 289 is going to equal 625. I want to make this equal to 0, so I'll subtract 625 from both sides. And so I get 2x squared plus 34x. And let me do that subtraction real quick here. So we've got 625, 289, so we get 336. So that's going to plus, sorry, minus 336 is going to be equal to 0. Okay, so we want to try to factor this. I have a common factor here, so I have x squared plus 17x, and half of 336 is 168, so minus 168 is equal to 0. And then I need to find the factors of 168, right, that add up to 17. So again, this is going to be a little bit of a journey here. So we got 168, 1 and 168. We've got 2 and 84. We've got 3 goes into that. I'm using the calculator to help me with this. So this is 3 and 56. Okay, I'm looking for a difference of 17. So if I 4 and 42, 5 doesn't go into it, but 6 does. So 6 and 56. Okay, 7 does not go into it. 7 does go into it, 7 and 24. 8 should go into it, and 21, 8 and 21. Okay, so we're getting close here, right? Here we've got a difference of, well, here we've got a difference of 17 right here. So we can actually stop, right? 7 and 24 look like our numbers. Okay, so 7 and 24, I have a positive number here, so my 24 is going to be positive and my 7 is going to be negative. And so I've got x minus 7 and x plus 24. Okay, and that tells me that x could be 7 or x could be negative 24. All right, so go back to our problem. They're talking about a triangle. They're talking about the legs of a triangle. So having the length of the short triangle leg be negative 24 is really ridiculous, right? That doesn't work. We don't talk about negative lengths like that. So, so it seems like our short leg is going to be 17. So our short leg is going to be 17, or sorry, not 17, 7 feet. 7 feet. And our long leg is going to be 17 more than that. So it's going to be 24. So 24 will be, so the long leg equals 24 feet. Okay. Okay, so the length of the shorter leg is 7 feet. The length of the longer leg is 24 feet. Now, there is another way to approach this problem. One, if the if the factoring was difficult, you could graph that and look it up, right? You can find the zeros and see how that factors out. That's one way to do it. The other way to do that is with a thing called Pythagorean triples. And so, Pythagoras, who is a famous mathematician who loved triangles, right? Triangles. So they were kind of obsessed with finding these integer numbers, right, that made a right triangle. And so they called those Pythagorean triples. And so there's a number of them, 1, 1, 2, 3, 4, 5, so that these combinations of numbers that satisfy that, right, a squared plus b squared equals c squared. And so, like, people have studied those for a long time, and you can actually just go out and look up a list of those. And so, that's kind of an interesting thing to do. And so, if I went out here and Google and I just looked up Pythagorean triples, and I spelled it right, you would see those. And so you could find a list of those. And so, like, here is a website. I like this website, but they actually give you a list. Like, here's the first, few Pythagorean triples. And so you could look up and see which one of these, the biggest number gives you a hypotenuse. And so we want a hypotenuse of 25. And so I could see right here, hypotenuse of 25. That has to be legs of 7 and 24. Okay, so that's another way to kind of work that problem. So, so if it has a hypotenuse of 25, that means the legs have to be 7 and 24. And so that's another way that I could approach this problem. Okay. So anyway, that's the last problem in there. It looks like I've submitted all the problems and we did okay on that. So I'm going to go ahead and end that the video here, and please let me know if you have any questions.